and it helps if I unmute myself. All right. Hey everyone, and welcome back to the show. Well, technically it's no longer the time to say Happy New Year, but because this is the first time that we're back on the stream, I feel it's okay to say Happy New Year. So, Happy New Year, everyone. My coffee maker stopped saying Happy New Year to me yesterday, I think. So, there you go. Today is January 14th, so it seems like January 13th or maybe 12th is the last day when at least my coffee maker producer thinks it's okay to say Happy New Year. So, I'll drink to that. And this is not coffee, but tea. And I I need this tea because I've been having a couple of technical challenges in the preparation for this. So let's see where this goes. I think it's going to be quite interesting. So, yes, I will remember to make everything full screen. I've got a projector here so I can see what is on screen. So hopefully I will notice if something is in the way. But today we're probably not going to spend a lot of time on Xcode because we're going to look into Genkit. But before we get into that, let's review where we are. And while you're watching and while people are trickling into the stream, just say hello and so tell me. Oh, maybe you can say Happy New Year in your language, if your language is not English, and if your language is English, then say Happy New Year in English. All right, so let's switch to this view here, and all right, so let's make a little bit more room. And I'm going to quickly run the application, and then we're going to have a look at where we're at. In the meantime, so after we had our holiday special with Noe, my special guest, I did continue working on the app. So there is a version of the app that has progressed a little bit more, but I decided to keep on using the version that I showed you last time. All right, so hopefully the simulator finishes booting up. Is your Xcode or your simulator boot up time as bad as this? I'm never sure if it's just me. Oh, here we go. All right. And there is Noe. Hey, Noe, welcome. So let's take a look at the application. So last time what we did was we worked a little bit on the authentication story, but the main functionality of the app is we have this list of artifacts or links that we collect, and then the user can click on a link and they can read the article or the link they saved in a simplified formatting, which removes any extra formatting and just keeps the basic formatting. And then you can go in and you can take a note and you can say stuff like, this is a really nice article. But you can also go in and generate a summary of this article. And for doing that, we're using Vertex AI, and we make a direct call to the model. So this is one of the AI features that we have in the application. And what I want to do next is I want to implement a feature that takes all of the articles that we have in the application and allows me to have a conversation with them. And to show you how this looks like, we're going to take a quick look at a version of the application that has progressed a little bit more. And this is on my my physical device here. So I've got a couple of articles in here, and you can see that a lot of them are about concurrency. In fact, all of them are about concurrency. So I can now go in and have a conversation with the application about this. Let's try, what do I need to know? Excuse me. What do I need to know about async await in Swift? So let's see what we get. Okay, so the answer is async await in Swift offers a more streamlined and readable way to manage asynchronous operations such as network requests, user breakdown of key concepts, and then it goes to explain asynchronous functions, the await keyword, main actors, the non-isolated keyword, the task modifier, and it even gives an example. And it provides a link to the blog that this is from. So you might be wondering how this works, and to give you a quick look behind the scenes, let me see if I can show you the database pages. I'm sorry. So I think it's probably this one. Let's take a quick look. No, it's not. I think it's this. Nope. Too many apps. Might be this one. So, no, it's not this one. But anyways, maybe this has the data that I'm after. No, oh, it's not. All right, let me find it for you. So, okay, so maybe it's this one. Yeah. So what I'm looking for are the embeddings. Unfortunately, it's not in here, so not a problem. I'm going to show you a slide deck to explain what this is about. So let me quickly find it. Open recent, and then building an exobrain. Here we go. Okay, so okay. we're almost there. Just need to find the slide deck I'm looking for. Okay, I've got it. Here we go. All right, so here is the slide deck I was looking for. So, if you imagine you need to teach a computer to find something that you talk about in plain language. So let's imagine we're looking at this text here, and this is just a plain text in English language that talks about something that a person did. It says, I went down to Aberystwyth on foot to buy some Welsh cakes and a few berries. When I finished doing my groceries, I had a latte at coffee number 1, where I met a few other speakers. And now let's imagine we want to find all the words that are food in the sentence. And I've highlighted them here. And Welsh cakes and berries and latte are items of food, and it's easy for us to understand that these are items of food. And it's also easier for us to understand that the words highlighted in pink here are not food items. So coffee sounds like it might be food, but it's actually the name of a place. Coffee number 1, that is a cafe. And groceries is an activity in this context here. And foot is, it sounds similar to food, but it's actually a part of my body. And berry in Aberystwyth is close to a berry, like a strawberry, but it's really part of that word. So in order to be able to reason about those pieces in a sentence, we need vector embeddings. And vector embeddings are numerical representations of a word, a sentence, or any other unit of text. And here is one such embedding, and that is actually the embedding for food, one of the words that were in the slide deck that I just showed you. And here is another vector embedding, and it's the embedding for foot. And you can see by looking closely that these embeddings are different. So an embedding is a very long list of floating point numbers, and I've shortened this down here to show just a few of those numbers, but in reality it's hundreds of numbers. And you can imagine that each of those numbers represents a quality on a dimension. So for example, it might specify the quality how eatable is an item, or how fruity is an item, or is it something that is artificial, or is it non-artificial? And you can imagine that there are plenty of dimensions like that, and you can position any item that you can think about on a very specific dimension. For example, this charger here is an artificial item, so it would rank pretty high on the is it artificial versus is it natural scale. So it would be almost 1.0 on the artificial scale, whereas the tea that is in my cup here probably falls somewhere in the middle, because it contains lots of natural ingredients like water or the milk, but I produced it, so it's somewhere in the middle. And you can take many of those dimensions and then specify the qualities of any item. And that is what we also use when reasoning about words. So an embedding or Yeah, a vector that you probably are familiar with are geo-coordinates. So for example, here are the coordinates for London or for a place in London, because London is pretty big and it spans a lot more than just like this particular point. And here are the coordinates for a couple of other places on the planet. And if you look at the pins on the map here, you can see that London and Paris are close to each other, and Boston and New York are close to each other, but Boston and London are a long distance. And you can also see that by looking at the coordinates here. So you can see that the coordinates for Paris are 48 point something, comma 2.35, whereas Boston is 42 point something and minus 71. So that's a long distance. And for us, it's easy to see because we are used to dealing with 2 dimensions. And for a computer, it's even easier. And computers can also deal with much larger dimensions or much higher dimensions. So how can we, by looking at this, we can say, well, Paris and London are close to each other, but that is because we're trained to do that. How would you do that if you try to do that mathematically? And the answer to that is you use something called cosine vector similarity. And by looking at those coordinate systems here, you can see that we've got a couple of angles here. And on the very left-hand side, we've got an angle that is, pretty narrow. And that means the vectors are very similar. So if you imagine that, those red arrows point from the 0 position to, let's say, a place on the planet. So, this one here might actually point to, I don't know, maybe Munich, and this other one might point to maybe Stockholm. And then we can compute the angle to say, well, are they close to each other? Are they similar? In the middle here, we've got an angle that is orthogonal. And it's a 90-degree angle. And that means, they are not very close, but also not very distant. So it's somewhere in the middle. And then we've got opposite vectors here. So this one points in one direction and the other one almost points into the other direction. And these are opposite vectors. And if you compute the cosine of those vectors, we get numbers. So if we compute the cosine of this angle here, the result will be close to 1, and that means it's similar. If we have a right angle, the cosine will be close to 0, and that means it's orthogonal. And if we compute the cosine of those 2 vectors here, it's close to -1, and that means it's opposite. And we can use this to compute the similarity of 2 vectors. So here we computed the similarity of vectors that are on planet Earth. But if we go back to this here, we can compute the vectors of words and then determine if they are close to each other or not. So what we want to do is we want to compute the embeddings, the vectors for our for the stuff that we've got in our knowledge base. So if we go back into the console and go into our project and look into Firestore, you see that we've got the full text for an article here. So we want to compute the embeddings for this full text and the embeddings for the full text of all the other articles. in order to be able to do this math, in order to determine if those if the full text is similar or unsimilar to the user's query. So let's take a quick look at the slide deck again. So yeah, I think this one is what we need. So let me play this. Not sure if you can see that, so let me play that in the window. Yeah. All right, and then I'll need to remove the chat. Okay, cool. So what you'll see is we've got our client application, which is currently covered by my webcam. So there we go. So we've got the client application, and this client application wants to perform a query because the user says, hey, I want to find all articles that talk about asynchronous programming in Swift UI or in Swift. So it makes a call to the backend, and then the backend makes a call to an embedding model. And this is an outdated slide deck, so this is still using a very old embedding API here, the POEM API. We're going to use text embedding Gecko. So it computes the embeddings and gets the embeddings back for the user's query. And then it takes those embeddings and goes to the database. And again, here I'm using Cloud SQL, which is outdated. And it gets back all the documents that are similar to the user's query. And then it goes to our model and asks the model to generate an answer based on those documents that are similar, and then sends back the answer to the client. So that is what we want to achieve. Okay. All right. So with that, let's take a look at how to implement this. And what we're going to do today is we're going to look at Genkit. So if you haven't heard about Genkit, it is a and let me remove the chat. No, this one. So Genkit is a framework that allows us to build AI applications. And you can run this anywhere. So you can run it on Cloud Functions, you can run it, you could even run it on a Raspberry Pi if you wanted to. And the reason why we want to use a framework like that is that we have to do a lot of things. So if you recall what I showed you on the slide deck, we need to connect to the database in order to fetch data. We need to connect to an embedding model to compute embeddings for the user's query. We need to take those embeddings, go to the database, fetch stuff from the database, then take the stuff that we get back from the database, go to the model and ask the LLM to generate some text based on the model, based on the documents we got back from the database. So there's a lot of stuff going on. And using a framework like Genkit makes that easier for us. So what I want to do first is to set up Genkit for my application. So let me find my window here. So here we go. So this is actually the prep, and we need to go up and up, and here we are. So I'm going to create a new folder for my backend implementation. And the first thing I want to do is create a Firebase project to host my Firebase functions. So to do that, let's have a quick look at the documentation, because the documentation helps with that. So I think it was in the deployment section, deploy with Firebase. Yep. All right, so the first thing that we want to do is we want to set up a Firebase project, and let's first verify that I'm logged in using the correct user. So I'm logged in using my personal account. We already have a folder, and now I'm going to initialize a Firebase project for Genkit. And we want to use an existing project, and it's going to be Sophia Dev Live. So this is the one that we want. Bump up the font. And the first thing we need to do is we need to initialize Firebase functions, because that is how we are going to host our backend. I'm going to host this on Firebase functions. I'm not going to use ESLint, but I want to install the dependencies. And while this is loading, I can stay hydrated. All right. So now it wants to know whether or where to install the Genkit CLI. A Genkit CLI is how I'm going to interact with the Genkit framework during development time. I'm going to install it just for this project. And now it's downloading the dependencies. And now we can choose which AI or which LLM we want to use. I'm going to use Google AI. It's worth noting that Genkit also supports a bunch of other LLMs, some of which are supported by the Genkit team itself, and some of those are supported by the community. So for example, if you wanted to use OpenAI, that's totally possible. There is a plugin for that, and you can use the OpenAI models. So now let's see what's going on here. Yeah, so just some configuration for my project. And I want to install a sample flow. All right, so now let's see what this has created for us. Okay, so oops. Yeah, I think I forgot to change into the folder. That happens. Oops. Oh no. Okay. I closed the wrong window. Let's see if we can get it back. Deskpad. Here we are. Okay. Deskpad display. Okay, so So let me first close VS Code. And then let's figure out what went wrong here. Okay. Taskpad, crop, none. Okay. Why is this taking the wrong window? Okay, so that's this one. Here we go. All right. Sorry for that. Okay. Okay, so first, let's create this folder. And then move this stuff over here. Hopefully I didn't forget anything. Yeah, this looks good. Go into the folder. Okay, cool. All right, so here we are. So this is our Firebase project for our functions, and it has a bunch of configuration files here. So this is a Firebase configuration file. This is the file that specifies which project I want to use. Here are our dependencies, and here is the main entry point into this backend application, and you can see that we've got a sample cloud function here, and here is the Genkit code that the process, the setup wizard created for me. So why don't we try to run this? So let's go here, and then let's make sure we're in the right folder, and then npm, I think there should be a run command, npm genkit start. npm run genkit start. All right, and it now tells us that it needs a API key, and I'm going to drag this off the screen so you don't see my API key. All right. Oh, there it is. Okay. All right, so, and once it's started, I can open the Genkit developer UI, and this developer UI allows me to interact with all the models and the flow that the setup process has created for me. So just to show that I can interact with the models, I can type a prompt, run it, and then I get a response back. That was pretty boring. How long can you say Happy New Year? There is no set time for saying Happy New Year. Well into the first few weeks of February. Wow, that's that's a lot of time. All right, so and let's see. We've got a couple of other models here. So I can choose between any of those models and run the same prompt. So let's see what Flash 8B has to say about this. Yeah, it's much more terse. And then we've got this flow here, and a flow is like a function, but it has a couple more features. So let's first invoke the flow. So it says menu suggestion flow. Let's see what happens. So I can provide a type of cuisine that I'm interested in, and then it will generate something here. And so this suggestion here says Schweinshaxe mit Knödel und Sauerkraut. So this is some German dishes here. Let's try something different. Let's try Swedish. And then we probably get Köttbullar mit Patatis auch Lingonsylt. That sounds nice. More adventurous. Reindeer stew. So, okay, so let's take a look at this flow to understand better what's happening. So, in our sample, Genkit sample TS file here, first of all, we have a bunch of imports to import the Genkit framework, to import the Google AI SDK that provides access to the models. We're importing the Gemini 1.0 Flash models. Very specifically, we also import Firebase auth and onFlow, and we'll see why that is in a moment. And then we configure Genkit. And at the moment, all it does is to initialize the Google AI plugin, and that is what required me to provide the API key in the environment. And then we have our menu suggestion flow. And as you can see, it is a function, and this function takes a couple of parameters. It takes a reference to our AI instance that we initialized up here. It defines the name that this flow is going to be visible in the developer UI. It indicates the input and the output schema, and if you remember here I provided a single string as the input, and the output also was a single string, which you can see here. And then we have an auth policy which doesn't do anything at the moment, but you can use it to specify, for example, that only signed in users can run this flow. So that is a lot more than a regular function would do, right? So a regular function just takes a couple of parameters, does something with it, and returns a result. And here we have a lot of stuff that's already baked in. And then we have this asynchronous body here. It takes one parameter, and that is the input that we get from the input schema. And we can use it here in this prompt, and what it does is it uses string interpolation to inject the text that I provided in the UI into this prompt here. And then in the next few lines, we make a call to the model, and the way how this works is we don't directly talk to the model, but we make a call to AI.generate, and we specify which model we want to use. So here we said we want to use Gemini 1.5 Flash, but if we wanted to use another model, we could just easily swap this out and provide the name of or a reference to another model. And then we send the prompt and a couple of configuration options for the model. And once the result returns in LLM response, it will be returned as a result of the function, right? So let's see if we can make a couple of changes here. So for example, let's change the prompt. So write write an outline for a blog post about subject. So save this and then go back into the developer UI and let's try Swift UI and Firebase. All right, and here we go. Blog post outline, Swift UI and Firebase, a powerful duo for app development. Introduction. Start with a compelling statement about the ease and power of building modern apps, and so on and so forth. So one of the cool things of Genkit and this developer UI is that we can now go in and take a look at the trace. So maybe that was a little bit quick. Let's go back and do that one more time. Swift UI and Firebase. Okay, so here is the result. The response that the model sent to us. And here we can look at the trace. And the trace is a representation of all the different pieces that this flow involved. So you can see that in this first step here, which is still called menu suggestion flow, and we should probably rename it. We can see the input, which is Swift UI and Firebase, and then we can see the output. So that is the response that the model sent us. And we can also see a couple of attributes like how long did it take, what was the start time, the end time, and so on and so forth. And the next step, if I click on generate here, that is the generate call that you saw in the code. And again, you can see the input, and the input now is a JSON object, and you can still see that we have a text in there, but you can see that what I provided as a user, Swift UI and Firebase, now is part of this longer text here because we use string interpolation to set up this prompt here. You can also see that this message here, from here to here, has a couple of attributes. For example, it says it was sent by the user, and here's the content. And you can see that this is an array, so you might imagine that instead of just sending text, we might be able to send more than just the text. So for example, we might be able to send a text and an image to reason about the image, right? So we might say, here's an image, please, make a suggestion or tell me what's in the image, or make a suggestion about what I might write about this image. And then in the output, you can see, again, this is a JSON object, and in the JSON object, we can see, the response is a message. It was generated by the model, and here is the content, and the response is a text. So that indicates the response might also be an image if we use a model that can generate images. And now we have the text, which is basically JSON formatted. And at the end, we can see all those additional parameters that give us some insight into how many input characters were there and how many output characters, which is important if you want to compute how expensive this call was. And for example, if you want to bill the end user for using this AI feature. And then further down, we can see that maybe the model generated a couple of candidates, and now we can take a look at all the different candidates. Okay, and then finally, here is the call to the model, and you can see what we sent to the model, or what Genkit sent to the model, and what the response was. And again, the attributes. So this is really nice because you can see exactly what's going on, and even for a very simple call like this, where we just talk to the model, this is already pretty helpful in figuring out if something went wrong. Okay, so let's go back here. And let me quickly take a look at the chat to see what people are talking about. Oh no. So let me look at the YouTube chat. All right. So Franklin asked, season 2, does that mean there might be a season 3? Maybe, who knows? But you can be sure that there will be more than just one episode. So we're already, what's the time? So we're already 51 minutes in. And I think implementing this whole thing will take a little bit more time, especially if I close windows that I shouldn't be closing. Noe wants to know if I've tried Google search grounding in Genkit. That is actually something that's pretty interesting. So, you know that if you ask a model to generate you some text, that text might or might not be 100% true. And if you want to ground it, that means you want to make sure that what the model generated actually reflects the truth. And that truth might be, you might depend on facts that are either public or that only you have access to. So for example, if you imagine that you're building an LLM application, an AI application that depends on data that is enterprise specific and resides in a database that is proprietary to your company, for example, then there is no way how the model can know about this, and you need to ground the model in the data that is in your database. And the approach that we're implementing here is doing exactly that. So we're using RAG, which means retrieval augmented generation, in order to ground the model in the data that the user has stored in the application. So what Noe is referring to here is grounding it in Google search, which means that the model will go out to the Google search engine and use the data that is available on Google search to verify what it generates. And that might or might not be interesting for what we're doing here. So it's definitely something that we can look into. Yeah, for sure. Cool. So we've got our flow here. And let's see. I think what we want to do next is, so let's go back into our console. So what we need to do is we need to compute embeddings for all the articles that the user stores into the database, right? So at the moment, we're just storing attributes like the URL, the reading time, the title, and the full text. And what I want to do is I want to compute embeddings for the full text, so that the user can then go in and use this chat functionality that I showed you in order to type their question and send this query to a Genkit flow which is implemented as a Cloud Function, and we'll then take the user query, compute the embeddings for this query, and then go to Firestore and tell Firestore, hey, can you find us the closest match here? So for example, if the user asked, hey, how can I implement asynchronous functions in Swift, it would find all the articles that are relevant to that topic. So what we need to do is compute embeddings, and that needs to happen whenever we write to the database. And in order to write to the in order to do something that happens when you write to the database, we need a trigger. So let's take a look at how to write triggers, and let's actually use the documentation. So let's go to Firestore, and then let's see if we can find documentation that talks about how to write Cloud Functions that connect to Firestore. So understanding Cloud Firestore, managing data, read data solutions, pricing, techniques and best practices. Nope. There we go. Extend with Cloud Functions for Firebase. So we have a bunch of event types: on document created, on document updated, on document deleted, on document written. And I mean, we could use on document created to run something that runs every time a document is created, but maybe we update something in the document that we need to react to. So I think I'd rather use on document written. So let's go back into our editor here, and then, let's take a look at a sample. Define a function trigger. On document written. So this looks nice. Let's take that. And let's go into our index file here. And let's move our imports up here. So we don't need those at the moment, so we can probably delete them or comment them. And then our documents are in the artifacts collection. So this here means the body of this function will be executed whenever a document is written, updated, or deleted in the artifacts collection, and we will get a variable called docID, which contains the document ID, which is, if we look at the database, this string here. So let's take a look at what we get from the event. So for example, we get data, and in data we get before and after. So that means when we write to the database, we can take a look at what was in the document before and what's in the document after we write. So I think as a start, what we need is we need to read the full text of the document and then do something with the full text and then write it back into the document, right? So probably after, right? So we write into the database, and after the write, we want to get what's after. And then we get the data, retrieves all fields in the document as an object, returns undefined if the document doesn't exist. Okay, so that sounds good. Const document equals document.data. Yeah. And then we want to write back. So we want to get a field, specify a document, event triggers. Oh, here we go. So const snapshot equals document.data, access a particular name. Okay, so event.data. Just copy this, right? Okay. So what's the problem here? Does not exist on type, change document. Oh, because this is on document created. Oh, here we go. So is possibly undefined. Okay, so we're using a question mark to nil coalesce, and then const full text. So now I want to read the full text. New value dot full text. So what's this? It's possibly undefined. If new value not equals undefined, how's that? You can see that I'm a Swift developer. All right. So now, let's see how we can write back. Reading data, writing data. Okay, so this is really, this is an important point. So if you, implement a function that is either on document updated or on document written, and then you modify the data, that means that you'll have another trigger event, and you want to prevent a continuous loop, an endless loop. And that means that you'll have to use this here, this condition, in order to prevent this endless loop. Okay, so we've got the new value, I don't know, can we just copy this? Yeah, look at that. We can't. Okay, let's see. Event.data. Okay. And then if data name is previous. Okay. And because we're only interested in the full name, full text, we're going to do it like that. Okay, so here in this function, they're incrementing a field that tracks the number of changes. So that's not what we want to do, but we want to write something back. So let me take this. Okay, so data.after. And the ref is the reference to the document. So now we're getting the document reference, so the exact document that we're writing to. And what we do is we will set a new attribute here. And let's put it, into tests. And we'll just write the const full text equals data dot full texts. Okay. So if this works, what it'll do is every time we write to a document in the artifacts collection, it will take the previous state and the new state. It will check if the full text on the previous state and the new state is equal. If it is, that means we're in the second round. It will just go back and return without doing anything. If it's not, it will take the full text and write it back into the document into the test field. So let's try to run this. And to run this, we need to go back to the console. And on the console, we want to run a Firebase emulator. So the Firebase emulator allows us to run Firebase locally on our development machine. Let's see if this works like this. Firebase emulator start. We want to run all the required emulators, but yeah. So this will only start functions and extensions. So this is not what we need. So I'll run Firebase init to add more emulators. So I want functions and I want Firestore. Let's define the ports. And now let's run this again. And now it will start up functions, Firestore, and extensions. All right, and this is the part where it takes a long time. I have no idea why. It seems to have to do with the ports that my machine has open or not. I found that if I quit the browser, it works better, or it unblocks it, but I don't want to close the browser now because there is stuff that we need. I don't want to risk run the risk of closing the wrong window. All right, while we're waiting, let's see. Can we get the chat back? Nope. But I can see what's going on in the chat here in the YouTube window. So Franklin asked, embeddings with no chunking. Well, yeah, so we will probably want to do some chunking here because the documents or the input data that we have can grow pretty large pretty quickly, right? So so what does chunking even mean? So imagine that you have a long document. Let's say somebody wrote a really long blog post about everything that you need to know about Swift UI and asynchronous programming. So a really long thing. And let's also imagine that the LLM that you want to use to generate an answer is either very expensive or it doesn't have a big context window. So, and it really doesn't matter what's the case, because in the end, you know, the strategy to deal with both situations is the same. So let's imagine that it's very expensive to send a lot of text in, right? So LLMs charge you by the number of tokens that you send in and that they return. And that means you want to make sure that you only send the data that's absolutely required to answer your question. And you might also want to prevent the model from generating super long text, right? So in our case, we want to have a concise summary. So that might also mean that we want to tell the model, hey, can you please keep it short and sweet? But let's talk about the input. So we've got this really long article. So we could potentially send the whole article to the model if it has a long context window and send the question that the user had and tell the model, can you please answer the question based on this context? But that might, you know, be overkill because the user's question might actually just be, you know, relevant for a small part of the document. So what we want to do is we want to slice the document into smaller chunks, and hence the name chunking, so that one, we only need to send in the stuff that's relevant, and two, we're only sending smaller pieces of text so that we don't consume as many tokens. So you want to slice documents or the input data into smaller pieces, compute embeddings for those smaller pieces, and then go into the database and say, okay, so here is the embedding with the user's question. Find me all the chunks that are most relevant to that, give them back to me. I'll glue them together, send them to the model together with the user question and get the answer. So that is what chunking is about. So we're definitely going to implement that further down the line. All right, now my emulator has started up and I can go into the emulator UI and you'll notice that it looks very different from the Firebase console, but we have access to most of, well, to some of the products, to the relevant ones that we need. So what we can do now is I'm going to create a new document here in the artifacts collection. And if you remember, we want to read the full text field, and I'll just put in a random string here, save it, and now we'll see if this works or not. So it does not work. Why? Okay, so here is a problem. Failed to load function definition from sources. Firebase error. There was an error reading function packages.json. Index.js does not exist. Can't deploy a Firebase function. Okay. Why is that? Let's take a look. So Oh, we didn't compile, right? Oh yeah, we did not. So I ran Firebase emulator start, and there is no, we need to compile our TypeScript source down to JavaScript. So let's do that first. npm run build. And now we should have a lib folder with all our code. And now we can run, let's see, is there a watch command? But watch, yeah, what we can do is, I'm going to open a second tab, npm run watch. What? npm run build watch. All right, so this is running the compiler in the background, and now in the foreground, we can run the emulator again. Hopefully, this is a little bit quicker. Maybe not. No, it's not. Yeah, and again, I'm not going to close the browser. Yeah, this is really strange. So one of the, and maybe when I did close the window, you saw my, you saw this settings screen. So I turned off handoff. The reason is that handoff and AirPlay consume a port, I think it's port 5001, which accidentally is one of the ports that Firebase tries to use for the emulator. So I was hoping that this might solve the problem, but it's not. So there's something else going on. And yeah, I need to figure out what's the problem. Yeah, I know. It is really, it started fairly recently, so I didn't do anything, right? But something has changed. So maybe there has been an update. Maybe I installed something. I tried a couple of things before the live stream, but none of them really worked. I mean, I can try one thing here. Let me see. So, for example, maybe this helps. Nope, it does not. The funny thing is, I thought it was Chrome. So I closed Chrome and then I used Safari, but Safari also seemed to have an issue. Okay, so let's see. This looks better. Let's go back into Firestore and create a new document. Full text. Hello. No. Oh. Wait. Okay, so something else is fishy. Failed to load definition from source. Functions YAML failed. It would be a shame if this prevented us from doing what we're trying to do here. Okay, maybe I'm using the wrong name. Full text. Let's add another document. Nope. Okay, let me start this up again. And maybe, so if this doesn't work, I think I'll need to figure out what's the reason why before we do the next one. Okay, so this looks better to me. Okay, so at least, okay, so at least now we know that something is wrong in our code, so we can do something about it. No, not here. Okay, so it's trying to read ref, and we are in index.js 20. Okay. Okay, so let's see. Index.js 20. Okay, after the ref. I wonder if that's the right way to do it. Let's look at the code that I wrote before. Okay, so, all right. So what I did here, okay, yeah, that makes sense. So that's one thing, and then data after. No, this is not the right way. Source index.ts. So here we go. Okay, let me take this, and then we're going to replace it here. Nope. Copy, paste. Okay, and then remove all of this. So this needs to be in the await. Okay, so if we don't have anything here, we will use an empty object. Same here. Then we have this comparison to make sure that we're not in an endless loop. And this should now work. Okay, let's give it another try. And here we go. So if you do it the right way, it does work. Okay. So that means we can do stuff when something is modified in the document. So let's take a look at the time. So we're already 1.5 hours in. I will, let's try to actually compute the embeddings. So let's go to the Genkit documentation, and let's look at how to compute embeddings. So this needs to be in the retrieval augmented generation section, and let's take a look at how to compute embeddings. So here is how to store stuff in a local vector store. We're targeting Firestore, so we don't have to use a local one. Define your index of flow. So this is about PDFs. This is about writing our own embedders. Okay, so what we need is something to compute the embeddings, because we just want to store them back to Firestore. Maybe we can start there. So so let's move this over here. Okay, so Genkit embed. Okay, go text embedding, we find a rag flow. This is the embedder. Chunking context. Okay, so it seems like the documentation does not have a piece that talks about specifically how to run the embedder. Yeah, so the call should be ai.embed. Let me see if it's documented elsewhere. So maybe if we go here, okay, so here is how to do the retriever, populate Firestore with embeddings. Here we go. All right, so this is what I was looking for. So let's copy this, go back into our code. Okay, so we now need a Genkit configuration. And this is here. So we'll take this, pull it over into our index, and now we need to do a couple of imports. Import Google AI. Okay, and that's it, it seems. Okay, and then text embedding gecko 001, and what we want to embed is the full text. So new data dot full text. Okay, let's see, and then we're gonna write the embeddings into the database, and let's see if that works, because this is an array of numbers. Maybe we need to specify a different field type. Okay, so this seems like it has reloaded. Let's go back into the console, add a new document, full text, hello. All right, there we go. So here are our embeddings. So this apparently worked. As you can see, this is quite a number of of fields. So let's scroll to the very bottom. Yep, so 767 fields. It's zero based, so it has 768 dimensions. All right, cool. So, and with that, we have a function that takes our input and computes an embedding for it and stores it back into the database. So in the next step, yeah, Franklin says number worked. I'm shocked. So let's, maybe let's see. I don't know if TypeScript really helps us here, because I think what we need to do technically is field value dot vector, right? And then embedding. So I was expecting something like that. And this should work too. But I mean, the other thing is easier to read. So let's logom ipsum, generate a sentence, 2 sentences. And boom. Yeah. Let's see. Interesting. Yeah. Okay, so it seems that we actually need to use a vector field, right? Because so this lorem ipsum here is where we use the vector field. Let's take a look at the code. So here it says field value dot vector. So I'm actively specifying the field type I want to use. And it says, well, here you've got an array of numbers, but it's in the underscore values field. And if you look at this one where we didn't do that, it's directly in an array. So I think, and it even says it's an array. So, and here it's a map, and then inside the map there is an array. So I think this one is the proper way to implement it. I wouldn't be surprised if the other one basically breaks. Okay, cool. So we can store our embeddings. So the next 2 steps really are, whenever the user enters something, we need to turn the user's input into an embedding itself, and then go to Firestore and say, well, here's an embedding. Can you please go ahead and find me all the documents that are close enough to that embedding, and use vector similarity search to do that, and then return me all those documents. And because we don't want to implement that ourselves, what we're going to do is we're going to use a retriever, and Genkit has Firestore retriever, here you go. So that's what we're going to do. We're going to use a Firestore retriever, but that's something that we're going to do next time, because we're already way over time. My phone says 9:41. That's not true. What's the real time? So it is 9:34. All right, so it was a little bit more chaotic than all the other times. Apologies for that. Also apologies for the very slow emulator suite. I have no idea what's going on there. Hopefully I'll be able to figure it out for next time. And next time we're going to implement the search feature. Thanks for tuning in. Next time will be next week. I'm going to post on social media, so it will be same day, same time. So set your alarm, and hopefully see you next week. Thanks for tuning in, and enjoy the rest of your day. Bye.